back to this channel. So today's lecture we are going to see the different characteristics of sewage. So as you all of know, the characteristics of particular sewage which decide the quality of that sewage, and depending on its different characteristics we will decide which treatment we are going to take for that particular sewage in sewage treatment plant. So today's lecture we are focusing on the different characterization. So first of all, you will attend this lecture, and in last 15 minutes we will have the question answering session if you have any. So let's we start. So this particular module covers the composition of sewage, different characteristics of sewage. So there are main basic three types of characteristics: physical characteristics, chemical characteristics, and biological characteristics. Then also, if we'll get time, then we will are going to see the aerobic decomposition and anaerobic decomposition processes or cyclic flow chart. So let's we start. First, the composition of sewage. What is mean by composition of sewage? The composition of wastewater varies widely, and this is partial list of what it may contain exactly, or what constituents involved in that particular sewage. That is known as called as composition. The water is more than 95%, which is often added during the flushing to carry the waste down a drain. So, in environmental engineering 2, in previous lecture, we have already seen the what is sewerage system and what is the use of sewerage system to convey the sewage which is coming out from the household properties to the sewage treatment plant. So to flow this sewage under the gravity flow, we are using a lots of water for that, for the flushing purpose. The pathogens such as bacteria, viruses, prions, worms are included in this sewage. And now non-pathogenic bacteria such as some impurities or inorganic materials or heavy metals. The organic particles such as feces, hairs, food, vomit, paper fiber, plant material, humus, etc. And the soluble organic materials such as urea, fruit sugars, soluble proteins, drugs, pharmaceuticals, etc. So that all constituents are the part of sewage, and that is called as the composition of sewage. And also the inorganic particles such as sand particles, grit, metal particles, ceramics, etc. So these all are part of composition of sewage. Then come to the point, the characteristics of wastewater. So again there is a difference between wastewater and sewage. The commonly unwanted water generated during the different activities is called as wastewater, and sewage, which wastewater we are called it as sewage. The wastewater is generated from the household area, from the kitchen, bathroom, sinks, WCs, etc. That particular wastewater is called as sewage. So sewage is generated from the household area. So what are the characteristics? The physical characteristics. Under physical characteristics, there are different parameters such as odor, color, temperature, turbidity. Under chemical characteristics, total solids, pH value, chloride content, nitrogen content, and fats, oil, and grease. And under biological characteristics, the most probable number or MPN of coliform bacteria, which will decide the colonies of bacteria or pathogenic bacteria present in water, and the biochemical oxygen demand, that is BOD. So all these terms are very important because they will decide the quality of that particular water. So there had some standards set by the Environmental Pollution Board and Central Pollution Board. So there had some standard values. If and we are not exceeding that value, suppose that sewage waste has the values greater than that set standards, that means the water get polluted. So let's we see one by one characteristics. First are the physical characteristics. The first parameter is odor. Odor means smell. You all of know. Odor means smell. The odor of the fresh sewage is not offensive, or practically it can be considered odorless. But as it starts to get stale, it begins to give offensive odor. So, as you know, in sewage, when decomposition takes place, in that biodegradation process, the methane gas is generated under the anaerobic reaction. Or suppose in some quantity, if that sewage is open to atmosphere, then aerobic reaction takes place and carbon dioxide is released. So because of the release of methane, carbon dioxide, hydrogen sulfate, the smell is occurs to that particular sewage after some time duration, or after that wastewater will get stale. Within 3 to 4 hours, all oxygen present in the sewage get exhausted or consumed by the microbes present in that sewage, and it starts emitting offensive odor by hydrogen sulfide gas, which is formed due to the anaerobic decomposition of sewage. The second parameter under the physical characteristics is color. The color of sewage indicates the freshness of sewage. That means if sewage is shown in transparent color, that means that sewage is not polluted. That means that water is clear water. If its color is grayish brown or yellowish, it indicates the fresh sewage. But with passage of time, or after 3 to 4 hours, as putrefaction takes place, putrefaction means the decomposition action or degradation, biodegradation process. That process is called as putrefaction. As putrefaction starts, it begins to get black in color. The color of the stale and septic sewage is black. What is meant by septic? When all the oxygen has disappeared from the sewage, then that sewage is called as septic sewage, and which is harmful to human being. The other colors may also be formed depending on the reaction takes place. The third important parameter is temperature. The temperature has an effect on the biological activity of bacteria present in the sewage. That means that biodegradation process depends on the temperature. If at higher temperature, the rate of that reaction of biodegradation process is high, and at the cold temperature, cold weather, the rate of biodegradation process of microbes is very slow. So it will depends on the temperature, and it also affect the solubility of gases in sewage. It also affects the viscosity of sewage. How? That means the temperature is inversely proportional to the viscosity. That means more the temperature, lesser is the viscosity of sewage. You know the viscosity property, and one example of viscous fluid is your sauce which has the sticky in nature, and not a flow rate is very high. So there is the formation of number of layers one on another. So that fluid we are called it as viscous. So your viscosity is temperature. Higher the temperature, lower is the viscosity, and lower the temperature, higher will be the viscosity. The average temperature of the sewage in India is about 20 degrees centigrade, which is near about the ideal temperature of sewage for biological activities. At higher temperature, the coupled with the lower dissolved oxygen activities can cause the serious problem in disposal of wastewater. That means at higher temperature, your dissolved oxygen get reduced or depleted in the natural water bodies or natural water courses, and lots of environmental concerns have takes place in form of the excessive growth of algae, eutrophication, etc., because of the lowering the range of oxygen because of higher the temperature. The next parameter under the physical characteristics is turbidity. What is turbidity? The sewage is normally turbid, representing the dirty water. So you know the meaning of turbidity. What is turbid water? That the color of turbid water is brown in color, right? Which include a lots of dissolved particles and suspended particles. Or the wastewater from the bath having other floating matter like the fecal material, feces of paper, cigarette ends, matchsticks, grease, vegetable debris, fruit skin, soap, etc., which impart the turbidity to water. The turbidity depends on the quantity of solid matter present in the suspension state. The turbidity can be determined by turbidity rod or by turbidity meter. For example, the Neflo turbidity meter, which is the instrument or a rod, which it is the digitalized instrument which define the turbidity of that particular water. The next are the chemical characteristics. So similar to physical characteristics, there are chemical characteristics. So first are the solids. So there are again solids are divided into total suspended solids, total dissolved solids and total solids. So let's we see one by one. The sewage normally contain 99.9% water and only 0.1% of total solids present in the sewage may be in any of four, that are in the form of suspended solid or dissolved solid or colloidal solid or settlable solid. Suspended solid means particles or solids are in suspension. They are not settled down by the force of gravity. Dissolved solid means the solids which has specific gravity less than specific gravity of water, that is dissolved in nature and when cannot be settled that dissolved particle easily by the force of gravity. Colloidal solids means there will be the formation of flock or colloidal particles, the cloudy structure, bulky structure. And the settleable solids are the bigger size particles whose specific gravity is greater than 1 or the greater than specific gravity of water. That settleable solids which can be easily settled down by the force of gravity. So these are the four types of solids. So suspended solids are those solids which remains floating in sewage. Dissolved solids are those which remains dissolved in sewage just as a salt in water. Colloidal solids are finely divided solids remaining either in solution or in suspension. And settleable solids are that solids which settles out if the sewage is allowed to remain undisturbed for a period for minimum 2 hours. So solids can be organic or inorganic. Organic means it will be biodegradable and inorganic means the example of inorganic solids are heavy metals, silt particles, sand particles, etc. About sorry about 45% of total solids are organic and the remaining 55% are inorganic. So the sewage is the combination of organic and inorganic solids. The inorganic matters consist of minerals and salt like sand, gravels, dissolved salt, chlorides, sulfates, etc. The organic matters consist of carbohydrates like cellulose, cotton, starch, sugars which are coming from the vegetable waste from the kitchen. The fats and oils received from the kitchen's garbages, etc. The nitrogenous compounds like the protein and their decomposed product including the waste from animals, urea, fatty acid, etc. So, the solids are the combination of all the proteins nitrogenous compounds in the wastewater. The amount of various kind of solids present in the sewage can be determined as following methods. First is the total solids. How we are determining the total solids present in that particular sewage. So we are called it representing that term is S1 in mg per liter, milligram per liter, total solids. It can be determined by evaporating a known volume of sewage sample and weighing the dry residue left. That means suppose there is one container, in that you have taken the 100 ml of sewage sample. So you can overnight dried this sample for 24 hours, and after evaporating all this water present in that sewage, so all these impurities present in that sewage, that are nothing but the total solids in milligram per liter. The mass of the residue divided by the volume of sample. Suppose the mass of the residue is 2 gram, divided by the volume of sample is 100 ml. Evaporated will give the total solids in milligram per liter of water sample. The next is suspended solid, S2. How we are determining the suspended solids? These are solids which are retained by the filter of 1 micrometer pores. So there are the filter paper which has the different micropore size. So we are passing this particular sewage through this 1 micrometer pore size filter paper. So the layer called non-filterable solids. Their quantity can be determined by passing the known volume of sewage through the glass filter and weighing the dry residue left. The mass of the residue divided by the volume of the sample will get the value of suspended solids. The next important is dissolved solids and colloidals. So how we are determining the dissolved solids and colloidals? The difference between the total solid and suspended solids will get the quantity of dissolved solid present in that sewage. The next is volatile and fixed suspended solids. Volatile means the particles which are evaporate. The total suspended solids may either be volatile or fixed. Fixed means they are remains stable in that particular sewage, and volatile means they will get evaporate. To determine their proportions, the non-filter residue is burnt and ignite at about 550 degrees centigrade in a muffle furnace for about 15 to 20 minutes. The loss of weight due to the ignition will represent the volatile solids in the sample, and the S2, that is suspended solid, minus volatile solids, which will give the fixed solid. So is it easy, guys? Easy to calculate each and every quantity of solids? Yes. The next chemical characteristics is pH value. pH is again the very important factor. The pH value of sewage indicates the logarithm of reciprocal of hydrogen ion concentration, and the pH value will decide the acidity and alkalinity of that particular sewage. The formula of calculating the pH value is the minus log to the H plus ions. It is thus an indicator of the acidity and alkalinity of sewage. There is the scale of pH, and value of pH is start from 1 and end to 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 7 is the neutral value. The 7 value represent the neutral value. The pH value less than sewage, that means the sewage is acidic in nature, and the pH value is greater than sewage, that means the sewage is alkaline in nature. The pH can be determined using the pH meter, or we are called it that instrument is potentiometer. So this is the particular pH scale, and these are some different constituents which has different pH value, as you can see. You can also check your daily routine, some product, the pH value of that. So you can check the pH value of your bath water. You can check the pH value of milk. You can check the pH value of pure water. You can check the pH value of soap. So each and every product has different pH values. So as you can see in this scale, the milk has a neutral pH value which is in the range of 6.5 to 6.8. So the pH paper is easily available, so you can buy it and just you do the small experiment. You check the pH values of different products or materials. So milk pH value is neutral. The value of pure water is also neutral. The value of soapy water is 12, that is alkaline in nature. The value of bleach, the liquid drain cleanser, has the higher pH value, that is alkaline in nature. The acid rain, battery acid, sulfuric acid, lemon, orange, which has pH value less than 7. That's why we are called it as the lemon and citrus fruits like the orange that are the acidic in nature. And this is the pH scale. The next chemical characteristics is nitrogen contents or nitrogen compounds. The presence of nitrogen in sewage is an indication of the presence of organic matter and may occur in one or more of the following forms. So, nitrogen is not available in a free nitrogen, but it is available in compound form. The free ammonia called the ammonia nitrogen, the albuminoid or the organic nitrogen, the nitrites, nitrates. So, these are the form of nitrogen. The free ammonia indicate the very first stage of decomposition of organic matter. Means when the decomposition start, there will be the presence of free nitrogen. But after the some specific time duration, when that process is finished, then your free nitrogen will get disappeared. The albuminoid nitrogen indicate or the organic nitrogen indicate the quantity of nitrogen in sewage before the decomposition of organic matter. The nitrates indicates the nitrates and nitrites are two important terms. The nitrates indicates the presence of fully oxidized organic matter in sewage, and the nitrite thus indicate the intermediate stage of conversion of organic nitrogen of sewage to the stable form. So in between that stage there will be the presence of nitrites, and these are very dangerous. So thus the indicating the progress of treatment. Their presence shows that the treatment given to the sewage is incomplete and sewage is stale sewage, whereas the presence of nitrate indicate the well oxidized and in front of us. Just a minute, guys. Okay. So organic nitrogen can be measured by adding the strong alkaline solution of KMNO4, that is potassium permanganate, to already boiled water sample and again boiling the same. The ammonia gas thus liberate is measured, which gives the quantity of organic nitrogen. The sum total of ammonia nitrogen is called as Kjeldahl nitrogen. So there is the instrument called as Kjeldahl instrument, which determine the quantity of ammonia present in wastewater. The nitrites are the dangerous, but as oxidization of nitrite to nitrate is very fast, it is generally not found in water bodies. But if the sewage contain the higher nitrates and if it is disposed of in water bodies like river, lake, sea, etc., then the nitrates content in the water body would increase. The higher quantity of nitrates adversely health of infants, causing the diseases called methanomegalemia, commonly called as blueberry disease, which is disease happening to the small children. Suffering from this disease may vomit. Their skin color may become a dark and may die in extreme case. So this is very dangerous disease. This is the nitrification and denitrification cycle. So as we have already discussed that the free ammonia is the indication of the sewage is the degradation process, decomposition process it just start. So after some time that ammonia will get converted into the nitrite. So nitrite is the intermediate state of ammonia and the nitrate conversion. Nitrite means the incomplete decomposition of sewage or stale sewage. It represents the sewage is stale in nature. But once the ammonia is fully oxidized, then it will be converted into the nitrate NO3, that is fully oxidized compound. So again the denitrification is happening in this cycle. So in denitrification again the nitrate will get converted into the nitrite and again nitrite will get converted into the free ammonia. The next chemical characteristics is chloride contents. The chlorides are generally found in sewage and are derived from the kitchen waste, human feces, and urinary discharge. The normal chlorides contents of sewage is 120 mg per liter. For exam point of view, this value is important. So what is the chloride content in sewage? Might be the external examiner will ask you that question. What is the range of chloride contents in sewage? That is 120 mg per liter. Whereas the permissible limit of chloride, what is permissible limit? Means it is the set standard values of chloride. That means whenever you are discharging this treated sewage into the water bodies like lake, sea, ocean, river, etc., then you have to set that value of chloride up to the 250 water bodies. So you have to maintain these values up to the 250 mg per liter. That is your permissible limit. It can be determined by titrating method. The titrating the wastewater with the standard silver nitrate solution using the potassium chromate indicator. So that is again the chemical process. That experiment you can do it in your laboratory. The next chemical characteristics is fat, oil and grease. The fat, oils and greases are derived in sewage from the discharge of animals and vegetable matter or from the garages, kitchens of hotels and restaurants, etc. Such a matter forms the scum on the top of the sedimentation tank. Scum means a floating material, the layer of oily layer which are formation onto the top of that surface of water, clogs the voids of the filter media and affect the diffusion of oxygen. They thus interfere with the normal treatment method, hence this detection and removal is important. Oil and greases are soluble in ether, hence for their determination the sample of sewage sample is first of all evaporate, leaving behind the oil and grease as a residue which is then weighted. The next chemical characteristics is toxicity. The heavy metals present in sewage in form of copper, lead, silver, chromium, arsenic, phenols, boron, cyanide. So all the detergent powders, pesticides, finishes that we are using for cleaning purpose, that includes all these toxic materials, are some of the toxic compound affecting the microorganism resulting in malfunctioning from the industrial waste. The next chemical characteristics are in form of sulfide, sulfate and hydrogen gas. The sulfides and sulfates are formed due to the decomposition of various sulfur containing substances in sewage. This decomposition also leads to evaluation of hydrogen sulfide gas, causing the bad odor. Beside causing corrosion of concrete sewer pipe, because of releasing of that hydrogen gas and carbon dioxide gas, the corrosive property of sewage is increases, and because of that there will be the chance of corrosion takes place of your pipe, sewer pipe. In aerobic digestion of sewage, the aerobic and facultative bacteria oxidize the sulfur and its compound present in sewage to initially form a sulfide, which ultimately break down to form sulfate ions, which is stable and unobjectionable end product. So similar like to nitrification and denitrification, there is the stabilized form of sulfide, it's sulfate. That means it will shows the wholly oxidized sulfur content in sewage that are not harmful. In an aerobic digestion of sewage, the anaerobic and facultative bacteria reduce the sulfur and its compound into the sulfide with evolution of hydrogen sulfide gas along with the methane and carbon dioxide gas, thus causing the very obnoxious odor. Next parameter is dissolved oxygen. Dissolved oxygen is very important term which shows the freshness of sewage. The dissolved oxygen is the amount of oxygen in the dissolved state in the wastewater. Its presence in treated wastewater effluent indicates that the considerable oxidation has been accomplished during the treatment stage. While discharging the treated sewage into the receiving water bodies, it is essentially to ensure that at least 4 mg per liter of dissolved oxygen is present in water. So, what is the dissolved oxygen of a natural water body? It's 4 mg per liter. So, we have to maintain the treated water dissolved oxygen content is 4 mg per liter. So, again, exam point of view, that question is frequently asked. What is the permissible limit of dissolved oxygen when we are discharging the treated water into the river? Your answer is 4 mg per liter. If dissolved oxygen is less than 4 mg per liter, the aquatic animals like fish, etc., are likely to be killed near the vicinity of disposal. So, for the survival of aquatic life, the value is important. The presence of dissolved oxygen in wastewater is described because it prevents the formation of obnoxious odor. The DO determination also helps to find out the efficiency of biological treatment. So, depending on its DO value, you will decide which treatment you have to taken for that particular sewage. The next important term is biochemical oxygen demand. So, there are two types of organic matter. One is the biodegradable or biological active, and next is the non-biodegradable or biologically inactive. The organic matter is often assessed in terms of oxygen required to complete oxidize the organic matter to carbon dioxide and hydrogen dioxide and other end product of oxidation. The biochemical oxygen demand, the definition is most important, guys. The biochemical oxygen demand is defined as the amount of oxygen required by the microorganism to carry out the decomposition of biodegradable organic matter under the aerobic condition. That means biochemical oxygen demand is nothing but the quantity, how much oxygen is required for the microorganism present in sewage to oxidize the impurities or organic matter present in that particular sewage. So it is nothing but the quantity of oxygen required to biodegradation of that particular impurities present in water. The BOD test is widely used to determine the pollution strength of domestic and industrial waste in terms of oxygen that they will require if discharged into the natural water body. So basically BOD will decide the quality of water. The pure water has BOD value must be 0. The drinking water which has 0 BOD value. So BOD is absent in drinking water. It is the one of the most important tests in stream pollution control activities. This test is of prime importance in the regulatory work and is studied designed to evaluate the purification capacity of receiving bodies of water. It is also useful in design of wastewater treatment plant and also measure the efficiency of some treatment process. The test is of prime importance in regulatory work and in studied designed to evaluate the purification capacity of receiving bodies of water. It is also useful in design of wastewater treatment plant and also measure the efficiency of the treatment processes. So basically that BOD values represent the efficiency of treatment process. The organic matter present in the wastewater may belongs to two groups. First is carbonaceous matter and second one is nitrogenous matter. The ultimate carbonaceous BOD of the waste is the amount of oxygen necessary for microorganism in the sample to decompose the biodegradable carbonaceous material. That is biochemical oxygen demand. And this is the first stage of oxidation and the corresponding BOD is called as first stage BOD. In the second stage, the nitrogenous matter is oxidized by autotrophic bacteria and corresponding BOD or nitrification demand. In fact, the polluted water will continue to absorb oxygen for many months and it is not practically feasible to determine this ultimate oxygen demand. Hence, the 5 days period is generally chosen for the standard BOD test. So, we are conducting the BOD test or find out the BOD value for 5 days. So, what is the procedure of conducting BOD test? So, initially, there are three bottles. So, initially, one is for calculating or determining the dissolved oxygen content for the first day. So whenever you have taken the sample, so your first stage is to determine the dissolved oxygen content, and after 5 days, so that water, by adding some chemicals, that water BOD bottles, you are taken to or kept it for the incubation period of 5 days. So after 5 days, all this organic matter will get oxidized. So microorganisms are using the oxygen present in that water, and all the impurities or organic matter present in that sewage will get oxidized to the stable form. So after 5 days, you are again check the dissolved oxygen content. So after 5 days, is your dissolved oxygen is wholly disappear, because that dissolved oxygen is consumed by the microbial activities for the decomposition of organic matter. So the difference between the initial TO and final TO is nothing but your BOD value for 5 days, and is about 60 to 70% complete, while within 20 days period the oxidation is about 95 to 99% complete. A constant temperature of 200 degrees centigrade is maintained during the incubation period. The BOD value of 5 days incubation period is commonly written as BOD5 or simply as BOD. Then BOD test. How we are conducting the BOD test? As I already explained, the sample is first diluted with the known volume of specially prepared dilution water. The dilution water contains how you can do the dilution. So suppose there is 100 ml of sample, sewage sample, then you can dilute it for 1000 ml of distilled water. The dilution water contains the salt and nutrients necessary for biological activities and phosphate buffer to maintain the pH around 7 to 7.5, that is neutral. Diluted water is fully aerated water. So basically we are providing the aeration for diluted water. The initial TO of diluted sample is then measured. The diluted sample is then incubated for 5 days, as I told, at 20 degrees centigrade. So how much temperature you have to maintain? 20 degrees centigrade for 5 days BOD. The DO of the diluted sample after the incubation period is then found. So the difference between the initial DO of the diluted sample after the incubation period is find out. The difference between the initial TO value and the final TO value will indicate the oxygen consumed by this waste sample in aerobic decomposition in 5 days. So that is nothing but your BOD value. So the BOD in mg per liter or ppm, that is part per million, is then calculated by using the equation. BOD is equal to DO consumed in the test by the diluted sample multiplied by volume of diluted sample divided by volume of undiluted sewage sample. So that is the formula of calculating BOD. The next important parameter is chemical oxygen demand. What is the difference between biochemical oxygen demand and chemical oxygen demand? So in biochemical oxygen demand, there is the microbial action. So in presence of microorganism, that biodegradation takes place. So we are not using the chemicals in that process. But in chemical oxygen demand, we are using some chemicals to oxygen fixation or to the settlement of organic matter or stabilize the organic matter. It is widely used as means of measuring the amount of organic matter in the waste. It can be used to measure the biodegradable as well as non-biodegradable organic matter. The COD test taken 3 hours in comparison to 5 days. BOD test is conducted for 5 days, but COD is conducted for 3 hours only. In COD test, a strong chemical oxidizing agent like potassium dichromate is used in the acidic medium to oxidize the organic matter present in waste. Almost all type of organic matter with the few exception can be oxidized by the action of strong oxidizing agent under the acidic condition. So we are adding the sulfuric acid or hydrochloric acid in that. The COD can be defined as the amount of oxygen required chemically oxidize organic matter using a strong oxidizing agent like potassium dichromate under the acidic condition. So that is the difference between BOD and COD. So that frequently asked question is on this. What is the difference between BOD and COD? So the sewage contain many microorganisms like bacteria, algae, fungi, protozoa, etc. The bacteria being the most predominant. Most of the bacteria found in the sewage are harmless, non-pathogenic bacteria. They are helpful in oxidation and decomposition of sewage. A little number of bacteria, however, are disease producing pathogens, that is pathogenic bacteria, which are the real danger to the health of public. So to remove this pathogenic bacteria, we are providing the disinfection process. So commonly used disinfectant is chlorine. Okay guys, so because of time restrictions, we will stop here. So I will just check your questions if you have any. To attend this lecture, if you are not understand it properly, if you have interest in that particular subject, then only you can attend this live lectures. Okay, then the otherwise no use of that to attending lecture. So this lecture is only for the sincere students.